All right, Chapter 5, Review. Number 1, when we see these two angles equal to each other, we know these two sides are equal to each other. So we can just set them equal to each other and solve. So I'm going to subtract 20 from both sides. That will give me 2x equals negative 14. And now I divide by 2, I get x equals negative 7. Now, this is an okay answer as long as it's an x. We can't have a measurement that's negative 7, but if I plug in negative 7 right here, I'll get negative 14 plus 20, which is 6. And that lines up. So a negative answer is okay as long as it's not the measurement of a side. Right? This one's tilted, but same idea. This is equal to that. So 2x plus 25 equal to 7. Minus 25. That gives us negative 18. And when I divide, I get negative 9, which again is okay for an answer, because if I plug that in, I will get 7. Number 3, the converse of the first two, I have the sides marked. Now be careful. A lot of people on previous tests said, oh, x is 40. It's not. Draw your arrows. That angle is equal to that angle, which means this is 40. So if those two are 40, that's 80. We've used 80 degrees up here. What's left? 180 minus 80, 100. So x is 100 degrees, not 40. Same idea here, except a little bit different. These two are equal to each other. So I've used up 80 degrees here, which we just did the math on. That's 100. But that 100 is being split up here and here evenly because those are equal to each other. So if I divide by 2, x is 50 degrees. All right, draw a picture. Solve for x. So ABC is an isosceles triangle. So, whoops. I'm going to draw a nice, that's not that great. That looks more like a right angle triangle. Let's try that again. That's better. So isosceles, we know these are equal to each other. AB and BC, okay, are equal. So these two are AB and BC. The common letter is B. So that's going to be right here. That's A, that's C. AB is 4x minus 3. BC is 2x plus 5. And AC is x plus 2. We really don't need that. But it says solve for x and the sides of each triangle. So in the end, we will plug in there and the perimeter. But right now, all we're going to do is set these two equal to each other. So 4x minus 3 equals 2x plus 5. Now, a common mistake I'll see is adding all those up to 180. All, this, this, and this. That makes no sense. Those are sides. 180 is degrees. So we're going to set these equal to each other and solve. So that's 2x. When I subtract, add 3, I get 8. X equals 4. That's the first answer, x equals 4. Now I'm going to plug it in here, or here, doesn't matter. I should get the same answer. 2 times 4 is 8, plus 5 is 13. Or 2 times 4, sorry, 2 times 2 is 4, my bad. 2 times 2 is 4. No, 2 times 4 is 8, plus 5 is 13, I'm right. Plugging in the wrong number. 4 times 4 is 16, minus 3 is 13. And if I plug it in here, 4 plus 2 is 6. So there's our three sides. And then the perimeter, I add those up. 13 and 13. So the perimeter is 13 plus 13 is 26, plus 6 is 32. All right, DEF is an equilateral triangle. So this one doesn't matter where I put the letters because that's not a D. They're all equal. So this, and this. So DE equals 4x plus 1. EF is 3x plus 10. And DF is 5x minus 8. I can set any two of these equal to each other. So 4x plus 1 equals 3x plus 10. I'm just going to do those two. Subtract 3x, subtract 1, and I get 9. And I plug in 9 anywhere. 9 times 4 is 36 plus 1 is 37. 9 times 3 is 27 plus 10 is 37. 9 times 5 is 45 minus 10 is 37. So the perimeter is 37 times 3, which is 111. Okay, find the angle measures. Okay, so I'm just going to go through and do what I can do. I have 80 plus 60. That's 140. Whoops. That means 180 minus 140 means this is 40 right here. Well, if that's 40, then that's 140 for two reasons. These two add up to the external angle, or 140 and 40 are supplementary. If 40 is there, that means 40 is here. Okay. Over here, this is the external angle for this triangle. So that means 40 plus this angle right here add up to 105. So that makes this 65. And right here is 180 minus 65. So that's 115. And this external angle adds up to these two. So that makes this 75 right here. Which makes this 75 right here because of vertical angles. And if these two add up to 115, that means this right here is 65. So everything's filled in. So angle 1 is 140. Angle 2 is 40. Angle 3 is 65. Angle 4 is 75. And angle 5 is 115. So there's a lot of ways to go through that, but that's the way I chose. All right, state whether these are possible and what proof. So here we have an angle and a side and a side, and immediately that is not a proof. ASS is not one we use, so that's no. Don't even have to look at the second one. All right, here I have an angle, and a side. Here I have an angle, and a side, so that is yes, angle, side. Here I have three angles, and that is not a proof. We do not have angle, angle. That does not prove congruent angles. I'm sorry, congruent triangles. Here it's not marked, but I should always immediately mark vertical angles. That gives me angle, side angle here, angle, side angle here. So that is yes, angle, side angle. Here I have angle, sorry, that is a side, SAS, SAS. So that is yes by SAS. Sorry about that, meant to stop it before the bell. And here we should always mark reflexive side, and that gives us SSS, SSS. So yes, by side, side, side. All right. You will see on your practice test that there's only going to be one proof on the final, and it's actually going to be fill in the blank. So it's going to be easier than this. But first thing we always do is write our given. So RS is congruent to UT, and RT is congruent to US, and that's given. And I also immediately go over and mark RS in UT, RT and US, and I should automatically mark this. When I mark it, I come over here and say ST is congruent to ST by the reflexive property. And I'm actually done. I can prove this. Triangle RST congruent to triangle UTS by side, side, side. All right. Save time. I'm just going to write that. Given NP is equal to PM. NP is perpendicular to PL. So I know these are 90-degree angles right here. But I want to state that. Okay? And I know this is equal to itself. So I'm going to say that angle NPL is congruent to angle MPL. I'm sorry. I'm going to say those are right angles. Okay, and that's the definition of perpendicular lines. Then I can say that NPL is congruent to MPL because all right angles are congruent. I should state that PL is congruent to PL by the reflexive property. And now I have SAS, SAS. So I can say that triangle NPL is congruent to triangle MPL by SAS. Need to pause this at any time, go ahead and do that. All right, so we know that CD, again, I'm just going to say this is all there and write given. So CD bisects AE. That means we have that. Okay? But we need to say that. So AC is congruent to EC. Definition of segment bisector. We also know that AB is parallel to CD. So I put these little triangles here. And we know that E is congruent to BCA. Okay? Now, because we have parallel lines, we should always be looking for corresponding angles. So we know that this angle is congruent to that angle because of corresponding angles. So we have to say that. Angle BAC is congruent to angle DCE. Corresponding angles are congruent. And then what we have here is angle side angle. And we're basically done. Triangle ABC is congruent to triangle C, D, E by A, S, A. And that is it. Answers follow.